Hello all, welcome to my channel Math Made Easy. In the previous videos, I solved question number 32. I'm going to provide link in the description box. Let's start with question number 33 in this video. Prove that the lengths of tangents drawn from an external point to a circle are equal. So okay, let's draw a circle. Let's say we have a circle and with center O. Let's say this is the exterior point P. Draw tangents from this exterior point. So we can draw two tangents from an exterior point to the circle, and these are the tangents, right? Let us say Px, Py are the tangents. Now, where the tangent touches the circle, we know that tangent can touch the circle at only one point. So this point is called point of contact. Let us say for Px point of contact is A and for Py point of contact is B. Right? Okay, now we need to prove that lengths of tangents drawn from an external point to a circle are equal. What do you mean by length of the tangent? See here, Px is a tangent here. We can extend this tangent to any length, right? So we cannot measure this length. So what do you mean by length of the tangent? Length of the tangent is a part of the tangent or the segment of the tangent from the external point P to the point of contact. Only this segment. That means, so here PA, length of the tangent is PA, and in this case from the external point P to the point of contact B. Only this segment is called length of the tangent. Hope this is clear. That means we need to prove that PA is equal to PB. Okay. Before proving this, we need to know few things. Alright. So what is that? Let us say we have a circle and draw a tangent. Let's say I am drawing a tangent here and the point of contact is, let us say this is point A. Right? This is the radius, this is center O. Now the radius drawn through the point of contact is at right angle to the tangent. So what is the meaning of that? We know that the point of contact is on the circumference, and any segment which joins the point of which joins any point in the circumference to the center is radius. So this point is the circumference. So if we join, this will become radius. We are drawing this radius through the point of contact, right? So if you draw and if we just draw a line segment here, your OB is also radius, OA is also radius, but this OA is joining to the point of contact to the tangent. So that's why this is the radius drawn through the point of contact will be at right angle to the tangent. So your OA is perpendicular to this tangent. Let's say this tangent is some B. So OA is perpendicular to AB. This you need to know in order to prove this. The radius drawn through the point of contact is at right angle to the tangent. Alright. Now let's see. We'll just write what is given, what we need to prove, and are there any constructions needed. What is given to us? We have a circle with center O. Given a circle with center O, and P is an external point, and Px and Py are tangents. Then what we need to prove? Okay, let's see whether any construction is needed. We'll write it later. Then what we need to prove? We need to prove that length of the tangent PA and PB are equal. PA is equal to P. This is what we need to prove. Okay, now let's see. We know that OA is radius, so join O to A and then join OB and join O to P also. Now we can see two triangles formed, AOP and then BOP, or OPA, OPB, right? So if we can prove that these two triangles are congruent, then by CPCT we can tell that PA and PB are equal, right? Now let's see how we can prove that these two triangles are congruent. Okay, what did we do in the construction part? Join O to A, O to B, and then O to P. Okay, now proof. We'll try to prove these two triangles are congruent. In triangle OPA and triangle OPB, we have OA and OB are equal. What is the reason for OA and OB equal? These are a radius of the same circle. Radius of the same circle are equal, or we can say radii of the same circle. Then we have OP common in both. OP is equal to OP, which is common. Then what else we have? We have radius drawn through the point of contact. So this OA is perpendicular to PX or XP, and then OB is perpendicular to PY. Right? So we have angle OAP is equal to angle OBP is equal to 90 degrees, since OA is perpendicular to OP and OB is perpendicular to PB. Now by which rule of congruency are they congruent? Now we have one OA is equal to OB, which is this is one side we have, and this OP, if you see, this is opposite to the right angle in this triangle, so this will become hypotenuse. And even for triangle OPB also, OP is opposite to the right angle B, so this is hypotenuse. We have hypotenuse same in both the triangles. And then we have angle OAP and angle OBP, both are 90 degrees. So this is right angle. So by RHS rule of congruency, we have triangle OPA is congruent to triangle OPB by RHS rule of congruency. Okay, therefore by CPCT, we can tell that PA and PB are, these are the corresponding parts of the congruent triangles. So PA is equal to PB, hence proved. It is just very simple. We just need to prove the congruency. That's all. Alright. Okay then. Let's go for the second part. Using above result, find the length BC of triangle ABC. Given that a circle is inscribed in triangle ABC, touching the sides AB, BC and CA at R, P and Q respectively, and AB is equal to 10 centimeters, AQ 7 centimeters and CQ is equal to 5 centimeters. Okay. So here we need to use the previous result, which is like length of the tangents drawn from an exterior point are equal. If you see here, a circle is inscribed in a triangle and ABC's triangle, AB, AC, BC are sides of this triangle. If you observe it carefully, if you take A is exterior point, right? If A is exterior point, AR and AQ are tangents, are length of the tangents basically. AB and AC are tangents and R and Q are the point of contacts. So AR and AQ are length of tangents. That means we have AR is equal to AQ because length of tangents drawn from exterior point are equal. Similarly, if we take B is the exterior point, then BR and BP are equal. BR and BP are equal. Right? Similarly, if we take C as the point of C is the exterior point, then CP and CQ are equal. CP is equal to CQ. Only this thing we need to know. Alright, see what do we have? We have AB is equal to 10 centimeters. Total AB is 10 centimeters. Out of that we know AQ is 7 centimeters. AB is 10 centimeters and AQ we have 7 centimeters. And then CQ is 5 centimeters. We need to find BC, right? BC is nothing but BP plus PC. So, since AQ and AR are equal, AR is equal to AQ. We know AQ is equal to 7 centimeters. That means AR is also 7 centimeters. This is 7 centimeters. So, total AB is 10 centimeters. That means BR will be 3 centimeters. And we know CP is equal to CQ. Since CQ is 5 centimeters, our CP also should be 5 centimeters, right? Then from point B, BR is equal to BP. We got to know BR is equal to 3 centimeters. So BP is also 3 centimeters. So BC is BP plus PC. So 3 plus 5, which is 8 centimeters. Hope this is clear. We'll write them down. Okay. So what do we have? Given AB is equal to 10 centimeters, AQ is equal to 7 centimeters and CQ is equal to 5 centimeters. Since AQ is equal to AR, write the reason. Reason being, tangents drawn from an exterior point or lengths of tangents drawn from an external point are equal. Right? So since we have AQ as 7 centimeters, AR is also 7 centimeters. Then we have AB is equal to 10 centimeters. So AB is equal to AR plus BR. So 10 is equal to AR is 7 centimeters plus BR. Therefore, we have BR is equal to 10 minus 7, which is 3 centimeters. Then we have BR is equal to BP. Again, same reason. BR is equal to BP. Tangents from the exterior point are equal. So BP is also equal to 3 centimeters. Then we have again CQ is equal to CP, and CQ is given as 5 centimeters, so CP is also 5 centimeters. We have BC is equal to BP plus CP, which is 3 plus 5 is equal to 8 centimeters. That's all. So we need to know how to apply the previous result. If you take A as exterior point, AR and AQ are equal. These are the length of the tangents drawn from the exterior point. So AQ is equal to AR. AQ value is given as 7 centimeters. So AR is also 7 centimeters. We have total AB. So AB is AR plus BR. So from this we get the value of BR. But again BR and BP are equal. If you take B as exterior point, BR is equal to BP. Same reason, length of the tangents drawn from external point are equal. Since BR is 3 centimeters, BP is also 3 centimeters. Then if you take C as exterior point, CQ is equal to CP. And since CQ is given as 5 centimeters, CP is also 5 centimeters. We need to find BC, which is the sum of BP and CP. So add BP and CP to get BC as 8 centimeters. Okay, that's all this question. See you in the next video. Thank you.